Ladies and gentlemen, before exchanging with you some expected views in the world energy market over the next 25-30 years, I want to formulate two introductory remarks. First of all, it seems to me impossible to anticipate whether an oil peak will come, since new discoveries have occurred repeatedly. To what extent shale gas, for example in Europe, will prove viable. Whether and when carbon capture and storage will become commercial. What role states will seek for nuclear power. How climate action across the globe will evolve. Social, technological and behavioral changes, also very delicate to predict, will also have a significant impact on the energy markets. So my considerations will be based on the scenarios as developed by the International Energy Agency and by the European Commission. Second remark, it is really not possible, ladies and gentlemen, to examine in 15 minutes all the structural aspects of the global energy problems. So, sorry, but I will not dwell on the geostrategic consequences of an energy policy in full and constant evolution. Of course, this is a very important impact. For example, what will be the situation of the Middle East if tomorrow the role played today by oil and gas will lose their representativity in favor of the renewables? But having said that, ladies and gentlemen, taking all new developments and policies into account, the world is still failing to put the global energy system onto a more sustainable path. Global energy demand is expected to increase by 1/3 over the next 25 years, rising from nearly 30,000 million tons of oil equivalent to around 70,000. With China, India and the Middle East accounting for 60% of this increase. Energy demand barely rises in our OECD countries. Fossil fuels will remain the principal sources of energy worldwide. Oil will be still an important fuel in the primary energy mix, but its share drops from 1/3 today to around 1/4 of total primary consumption. Coal demand continue to rise. Its share in total energy demand will be as high as the share of oil. The demand of natural gas is projected to increase with 50% all over the actual level, going from 1/5 of total demand to more than 1/4, catching up with coal. The share of renewable, including biomass, in the world primary energy demand nearly doubles from 10 to almost 20%. This increase is underpinned by incentives to overcome market barriers, falling technology costs, rising fossil fuel prices and carbon pricings. Most of the growth occurs in the power sector. This means a near tripling in actual generation. Nuclear power became more uncertain after the accident at the Fukushima nuclear power station. New installed capacity will hardly compensate closed capacity all over the world. Its total capacity will be fairly close to today's level. I believe it is important to understand the underlying trends that are shaping the new energy landscape that our grandchildren will inherit. First of all, changes in energy demand can be significantly influenced by the manner in which governments intervene in the markets to tackle energy-related challenges. But nonetheless, fundamental energy trends persist, such as rising incomes and population push energy needs higher, energy market dynamics increasingly determined by the emerging economics, fossil fuels meet most of the world's energy needs, and providing universal energy access to the world's poor remains an exclusive goal. With an expansion of the global economy and an increase of nearly 2 billion in world's population, more energy will be needed to satisfy growing demand, even though new policies and programs are put in place to encourage energy savings. Secondly, emerging economies will determine the dynamics of energy markets. Their share of global primary energy demand continues to rise, reflecting their faster rates of growth of population, economic activity, urbanization, and industrial production. This, combined with energy-saving programs and certain saturation effects in energy demand in the mature industrial economies. Thirdly, fossil fuels will continue to meet most of the world's energy needs despite the persistent demand for renewable sources rises at a faster rate, giving them a considerable higher share of the energy mix. This includes that emissions of carbon dioxide due to burning fossil fuels, representing by far the largest source of global greenhouse gas emissions, continue to rise, putting the world on a path that is consistent with the long-term average global temperature increase, largely above levels that prevailed at the start of the industrial era. The fourth trend is the failure to provide universal energy access to the world's poor. More of 95% of these people are in either sub-Saharan Africa or developing Asia. Around 1 billion people will still lack access to electricity, and nearly 3 billion people will rely on traditional biomass for cooking. Ladies and gentlemen, nearly $1 trillion in cumulative investment is needed to achieve universal energy access by 2030. Energy developments, and that's my additional element, energy developments in the United States are profound, and their effect will be felt well beyond North America and the energy sector. The recent rebound in the US oil and gas production, driven by upstream technologies that are unlocking light tight oil and shale gas resources, is spurring economic activity with less expensive gas and electricity prices, giving industry a competitive edge and steadily changing the role of North America in global energy trade. By around 2020, the United States is projected to become the largest global oil producer, overtaking Saudi Arabia until the mid-2020s, and starts to see the impact of new fuel efficiency measures in transport. The result is a continued fall in US oil imports to the extent that North America becomes a net oil exporter around 2030. This accelerates the switch in direction of international oil trade towards Asia, putting a focus on the security of the strategic routes that bring Middle East oil to Asian markets. The United States, which currently imports around 20% of its total energy needs, becomes all but self-sufficient in net terms, a dramatic reversal of the trend seen in most other energy importing countries. Ladies and gentlemen, energy prices are another key determinant of energy trends. Coal prices rise less rapidly than oil and gas prices as a result of strong competition from gas in power stations and abundant coal resources. Actually, the ratio of natural gas to oil prices remains on an energy equivalent basis lower than ever before, due in large part to brighter prospects for unconventional gas, most of all shale gas. Last of all, the rate at which the efficiency of current technologies improves and new technologies are adopted will be a crucial determinant of future energy trends. Uncertainties relate to the prospects for carbon capture and storage, solar power, advanced biofuels, advanced vehicle technologies, and nuclear power. And I repeat, taking all new developments and policies into account, the world is still failing to put the global energy system onto a more sustainable path. Therefore, a new global energy landscape is absolutely necessary. The global energy map needs changes with potentially far-reaching consequences for energy markets and trades. Let us say first of all a word about energy efficiency. Energy efficiency is widely recognized as a key option to reach a more sustainable evolution. Although the specific steps will vary by country and by sector, there are a lot of areas that need to be addressed. Energy efficiency needs to be made clearly visible by strengthening the measurement and disclosure of its economic gains. The profile of energy efficiency needs to be raised so that efficiency concerns are integrated into decision-making throughout government, industry, and society. Policymakers need to improve the affordability of energy efficiency by creating and supporting business models, financing vehicles and incentives to ensure that investors reap an appropriate share of the rewards. By developing a mix of regulations to discourage the least efficient approaches and incentives to deploy the most efficient, governments can help push energy efficient technologies to the mainstream. Monitoring, verification, enforcement activities are essential to realize expected energy savings. These steps would need to be underpinned by greater investment in energy efficiency governance and administrative capacity at all levels. The current efforts of policymakers fall well short of tapping its full economical potential. In the last year, major energy-consuming countries, of course, have announced new measures. China is targeting a 16% reduction in energy intensity by 2050. The United States has adopted new fuel economy standards, and as you know, I suppose the European Union has committed to a cut of 20% in its 2020 energy demand. And Japan aims to cut 10% from electricity consumption by 2030. The measures will help to speed up the disappointingly slow progress in global energy efficiency over the last decade. But even with these and other new policies in place, a significant share of the potential to improve energy efficiency, 4/5 of the potential in the building sector, and more than half in industry still remains untapped. Let's examine in a few words the situation of the renewable sources. Renewable sources have to take their place. A steady increase in hydropower and the rapid expansion of wind and solar power, with the help of subsidies to introduce them, has to cement the position of renewable energy as an indispensable part of the global energy mix. A rapid increase in renewable energy will be stimulated by falling technology costs, rising fossil fuel pricing, and higher carbon pricing, and in the beginning stage by reasonable subsidies. This means that subsidy measures to support renewable projects at their starting point need to be adjusted over time as capacity increases and as the costs of renewable technologies fall, to avoid excessive burdens on governments and on consumers. The world's demand for electricity grows almost twice as fast as total primary energy consumption. Actually, the challenge to meet this demand is heightened by the investment needed to replace aging power plants. 1/3 is needed to replace plants that are retired. Half of all new capacity, even more if possible, has to be based on renewable sources of energy. Even then remains coal the leading fuel for power generation. Certainly, if nuclear power plant investments were scaled back after the Fukushima disaster, even France has recently joined the countries with intentions to reduce their use of nuclear power, while its competitiveness in the United States and Canada is being challenged by relatively cheap natural gas. While nuclear output still grows in absolute terms, driven by expanded generation in China, Korea, India, and Russia, its share in the global electricity mix falls slightly over time. Ladies and gentlemen, each year that passes, the climate goal of limiting the warming up of the Earth becomes more difficult and more costly. Unless carbon capture and storage is developed in short time, no more than a fraction, 1/3 is the figure defended by the International Energy Agency. So no more than 1/3 of the known reserves of fossil fuels may be consumed in the next 25 years, limiting as such the warming up of the planet. Short-time actions are more than necessary, knowing that CO2 emissions allowable at that time are already locked in for 4/5 by existing power plants, factories, buildings, etc. If no action is taken in the next 3 to 5 years, all the allowable CO2 emissions would be locked in by energy infrastructure existing over 5 years. These findings underline the importance of carbon capture and storage as a key option to mitigate CO2 emissions, but its pace of development remains highly uncertain, with only a handful of commercial scale projects currently in operation. And so the question raised, will coal remain a fuel of choice in a more sustainable development of world's energy markets in the near future? Well, the use of coal continues as the backbone of the power sector, especially in the emerging economies in Asia, China, India, but also in industrial countries. Coal indeed remains almost the cheapest generation option. The policy decisions carrying the most weight for the global coal balance will be taken in Beijing and in New Delhi. China and India account for almost 3/4 of projected non-OECD coal demand growth. China's demand peaks around 2020 and is then steady to 2035. Coal use in India continues to rise, and by 2025 it overtakes the USA as the world's second largest user of coal. Coal trade continues to grow to 2020, at which point India becomes the largest net importer of coal, but then levels off as China's imports decline. The sensitivity of these trajectories to changes in policy, the development of alternative fuels, and the timely availability of infrastructure create today much uncertainty for international steam coal markets and prices. Well-designed government policies can reduce emissions from coal use essentially in one of four ways, provided they bring forth the necessary investments. First, energy can be consumed in a more efficient manner, requiring less primary energy, including coal. Secondly, existing technologies that use coal much more efficiently can be deployed, particularly in the power sector, which accounts for 2/3 of global coal use. 3, coal's share in the energy mix can be reduced through policies that encourage its replacement by lower emission energy sources, such as renewable, nuclear, and even natural gas. And finally, new technologies, such as underground coal gasification, and especially carbon capture and storage technology, given sufficient, substantial, and successful financial support, can reduce emissions from coal use in power plants and even in some industrial facilities still using coal for steam production. Government policy is an important factor in managing oil demand, but other factors play a key as well, notably economic activity, population, prices, and technology. And all these factors, ladies and gentlemen, are interlinked. In any way, policymakers, in view to reduce oil demand, have to take into account that inertia and technology lead times can affect the use of oil, because it seems that consumers buy new equipment only when the existing cars are retired. Ladies and gentlemen, as I see that the 15 minutes are not longer expected, I'm going to some conclusions. Recently, the coming up of unconventional gas, most of all shale gas, and in the very near future, probably a boost of unconventional oil, will shift world's energy concerns from the production to the demand side. And this, of course, implies a lot of revision of our energy policies. And let me conclude to sum up again all the challenges I mentioned before, and which have to be solved in a very short term. First, let us avoid, with the help of regulatory measures, energy-saving programs, more efficient equipment, the use of renewable energy, and even taxes, that consumption of fossil fuels continue to grow even more than it is predictable today, limiting warming up beyond a level insupportable for world's climate. Secondly, Let us make sure that maximum potential of renewable energy can be installed as soon as possible. Let us take sufficient measures, subsidies, other government actions, that the upcoming trend of lower fossil fuel prices do not disturb the penetration of renewable energy in the market. 3. Although we cannot avoid the use of fossil fuels to cover world's energy needs, let us stimulate the use of the fossil fuel that has the lowest carbon footprint. And let us reactivate research and development in more efficient energy-using equipment and cars, and maximize projects to carbon capture and storage. Let me conclude by a supplementary warning coming from the World Energy Outlook 2012, and I quote, "Water is growing in importance as a criterion for assessing the viability of energy projects, as population and economic growth intensify competition for water resources. In some regions, water constraints are already affecting the reliability of existing operations, and they will increasingly impose additional costs. In some cases, they could threaten the viability of projects. The vulnerability of the energy sector to water constraints is widely spread geographically, affecting, among others, shale gas development and power generation in parts of China and the United States, the operation of India's highly water-intensive fleet of power plants, Canadian oil sands production, and the maintenance of oil field pressure in Iraq. Managing the energy sector's water vulnerability will require deployment of better technology and greater integration of energy and water policies." So, as you see, our energy challenge is becoming more and more complex. The global energy sector will need to invest, and that's very impressive, half of current world GDP on the next 2 decades in order to address all the challenges and expand, transform, and adapt the energy infrastructure. In order to guide such a transition towards energy sustainability, we will need global agreements and regulations on energy and climate policy. This energy sustainability has to be based on 3 core dimensions: energy security, social equity, and environmental impact mitigation. Thank you.